Welcome to IELTS Self-Peep MasterPrep, your trusted source for real exam-based practice tests. Every test you see here is inspired by current exam trends, and each one comes with full model solutions to help you master every section. Here's our daily schedule. IELTS tests drop every morning at 7:30 a.m. Eastern, and CLP tests every evening at 5:30 p.m. Eastern. No matter which exam you're preparing for, we've got you covered every single day. Are you ready for today's test? Give it your best shot and comment your score. The top 5 scorers will be featured in our monthly Achievers newsletter and awards. Want your name included? Let's begin.
Section 1. You will hear a woman booking a place on a guided city tour. First, you have some time to look at questions 1 to 10. Now listen carefully and answer questions 1 to 10.
Good morning, Bath City Tours, Craig speaking. How can I help you today?
Oh, hello. I'm ringing because I'd like to book places on one of your guided tours, please.
Of course, I'd be happy to help with that. Could I start by taking your name?
Yes, it's Patricia Thornbury.
Lovely. And is that Thornbury spelt Thornbury?
That's right, yes.
Great. And could I have a contact number for you, Patricia?
Sure. It's my mobile 07845 329016.
Let me just read that back. 07845 329016.
That's it, yes.
Perfect. Now, we've got several tours running at the moment. Did you have a particular one in mind, or would you like me to go through the options?
Well, I had a look at your website last night, actually, and I was quite interested in the one called, the River Heritage Tour. It looked really fascinating.
Oh, that's a wonderful choice. It's one of our most popular ones. It takes you along the old canal path and through some lovely Georgian architecture. Now, what date were you thinking of?
We were hoping for the 27th of May, if there's still space.
The 27th of May, let me just check the system. Yes, we do still have availability on that date. How many people will there be in your group?
There'll be 3 of us altogether, myself and 2 friends.
That's fine. So 3 places on the River Heritage Tour for the 27th. Now, I should let you know about the meeting arrangements. You'll need to come to Cathedral Square. Do you know where that is?
I'm not sure actually. Is it near the main shopping centre?
It's just behind it, actually. If you come out of the north exit of the shopping centre, you'll see the cathedral straight ahead, and the square is right in front of it. There's a large stone fountain we gather next to that.
Oh right, lovely. And what time does the tour start?
The tour sets off at 9:45 in the morning. We do ask people to arrive about 10 minutes early so we can get everyone registered and sorted before we head off.
9:45, got it. And roughly how long does it last?
It's about 3 hours, so you'd be finished around lunchtime. One thing I should mention, because part of the route goes along the riverside, we do strongly recommend that everyone brings a waterproof jacket, even if the forecast looks fine. The weather can be a bit unpredictable down by the water.
Oh, good to know. I'll make sure we all pack one. Now, I saw something on your website about a seasonal promotion. Is that still running?
Yes, it is. If you enter the discount code when you pay, you'll get 15% off. The code is SPRING40, that's all one word, all capital letters.
Brilliant. Spring40. I'll definitely use that. So how do I go about paying?
Well, you can pay by credit card over the phone right now, or alternatively we accept bank transfer if you'd prefer to do it that way.
I think I'd rather do it by bank transfer, actually, if that's all right. I don't have my card on me at the moment.
That's absolutely fine. I'll send the bank details to your mobile by text message once we're done here. We just ask that payment is received at least 48 hours before the tour date.
No problem at all. I'll get that sorted today. Thank you so much for your help, Craig.
You're very welcome, Patricia. I'll send that text through shortly. We look forward to seeing you and your friends on the 27th. Have a lovely day.
Thanks, you too. Bye.
That is the end of section 1. You now have some time to check your answers to section 1. Section 2. You will hear a University Open Day presenter describing campus buildings. First, you have some time to look at questions 11 to 20. Now listen carefully and answer questions 11 to 20.
Good morning, everyone, and welcome to Ashford University's Open Day. My name is Laura Henson, and I'm the Student Experience Coordinator here. I'll be walking you through the main campus buildings over the next 20 minutes or so, and then we'll finish with a short question and answer session. Let's begin right where we're standing, the Henderson Building. This is the newest structure on campus, completed just last September. A lot of people assume it's the main library, but it actually houses our Student Services Center, including admissions, financial aid, and careers advice. It was funded entirely through a donation from a private benefactor rather than from government grants or tuition fees. Now, if you look to your left, you'll see the Oakwood Library. It holds over 350,000 volumes, though what students love most is that it's open around the clock during exam periods, that's 24 hours a day, 7 days a week. During the rest of the year, it closes at midnight. There are 6 floors in total, and the top floor is reserved exclusively for postgraduate researchers. Moving along the path here, we come to the Jennings Sports Complex. It was originally built in 1982, but it underwent a major renovation 2 years ago. The complex now includes an Olympic-sized swimming pool, which replaced the older, smaller pool that had been there since the building first opened. The complex is free for all enrolled students, though staff members pay a small monthly fee of £15. Across the courtyard is the Whitfield Arts Centre. This is where our performing arts and music students spend most of their time. It contains 3 rehearsal studios and a main theatre that seats 420 people. The center is especially popular because it was designed by the award-winning architect Grace Okafor, who's known for her innovative use of natural light. Now let me point out a few other facilities you'll want to know about. The Martin Hall cafeteria has just been refurbished with a brand new vegetarian and vegan menu, which was introduced after feedback from students. The Brook Building, our engineering workshop, recently had solar panels installed on its roof, making it the first carbon-neutral building on campus. Over to the east side, you'll find the Campion Health Center. It now offers a same-day appointment system, so students no longer need to book days in advance. And finally, the Linden Computing Suite has doubled its number of workstations. It went from 60 to 120 to cope with growing demand from our expanding computer science department. Right, that covers the main campus buildings. If you'd like to follow me now, we'll head inside the Henderson building for refreshments before the afternoon program begins.
That is the end of Section 2. You now have some time to check your answers to Section 2. Section 3. You will hear two students and a tutor discussing a laboratory experiment on water filtration. First, you have some time to look at questions 21 to 30. Now listen carefully and answer questions 21 to 30.
Dr. Evans, thanks for meeting us. Sarah and I wanted to go over the results from our water filtration experiment before we submit the final report.
Of course. I've had a quick look at your preliminary data. Before we get into the details, tell me, what was your main objective for this experiment?
Well, we originally considered testing chemical purification methods, but we decided in the end that comparing the effectiveness of 3 natural filtration materials would be more practical and relevant to the module.
Good. And which 3 materials did you settle on?
We used sand, activated charcoal, and crushed ceramic. We measured how well each one removed impurities from contaminated water samples.
Right. Now, how did you collect your contaminated water samples?
We gathered them from the campus pond. Tom suggested using tap water with added contaminants, but I felt that natural pond water would give us more realistic and varied impurity levels, and Dr. Evans, you actually recommended that approach in the briefing.
I did, yes. Natural sources introduce variables that make the analysis much richer. So, what about the filtration apparatus? Did you build it yourselves?
Yes. We constructed 3 separate columns using plastic tubing. Each column held one of the materials. The whole setup phase took longer than planned, honestly, about 5 hours instead of the 2 we'd estimated, mostly because cutting the tubing to identical lengths was fiddly.
That's quite common. And the actual filtration process, how did that go?
The charcoal filter performed surprisingly well. It removed nearly 92% of the dissolved organic compounds, which was better than expected given the simple setup we had.
The sand was decent too, around 70% removal, but the ceramic was the most challenging part of the whole experiment. It kept clogging, and we had to restart the flow multiple times.
Clogging is a known issue with crushed ceramic. Did you try adjusting the particle size?
We did, actually. We crushed it into finer granules for the second trial, and that helped somewhat, but it still underperformed compared to the other two materials.
Interesting. Now, regarding your data analysis, I noticed you used a simple percentage-based comparison. Have you thought about applying any statistical tests?
Not yet. Sarah and I discussed it, and we agreed that the statistical analysis needs more research on our part. We're not entirely confident about which test is most appropriate for this type of data.
I'd suggest a one-way ANOVA since you're comparing 3 groups. I can point you to some resources. What about the written report? Where are you with that?
The introduction and methodology sections are done. Tom drafted the results section last night. We still need to write the discussion and conclusion.
For the discussion, I think we should focus on explaining why charcoal outperformed the other materials. The literature suggests its porous microstructure is the key factor.
Absolutely. You should also address the limitations, the ceramic clogging, the sample size. Speaking of which, how many trials did you run per material?
We ran 5 trials each. We wanted to do more, but we ran out of pond water samples and lab time.
5 is acceptable for this level. One last thing, your deadline is Friday. I'd recommend having a complete draft by Wednesday so I can give you feedback before submission.
That sounds very doable. Thanks, Dr. Evans. We'll have everything ready by then.
Yes, thank you. This has been really helpful.
That is the end of section 3. You now have some time to check your answers to section 3. Section 4. You will hear university lecture on the history and future of space telescopes. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Good morning, everyone. Today I'd like to take you through the remarkable story of space telescopes, instruments that have fundamentally transformed our understanding of the universe. We'll trace their development from early conceptual origins through to the cutting-edge missions planned for the coming decades. By the end, I hope you'll appreciate just how pivotal these instruments have been to modern astrophysics. So let's begin with the rationale for placing telescopes in space in the first place. Ground-based observatories have always suffered from a significant problem: the Earth's atmosphere. The atmosphere absorbs and distorts incoming light, which limits the clarity of astronomical images. As early as 1946, the American astrophysicist Lyman Spitzer published a paper arguing that a telescope positioned above the atmosphere would achieve far superior resolution. His proposal was visionary, but at the time the necessary technology simply didn't exist. It took decades of advocacy before funding was finally secured. The project that eventually emerged was, of course, the Hubble Space Telescope, which was launched in 1990. However, almost immediately after deployment, scientists discovered a serious flaw in Hubble's primary mirror: it had been ground to the wrong shape. The resulting images were blurry, and the whole program faced severe criticism. It wasn't until a shuttle servicing mission in 1993 installed corrective optics that Hubble began delivering the spectacular images we associate with it today. Now, Hubble's contributions over the following 3 decades were extraordinary. It helped astronomers measure the expansion rate of the universe with unprecedented precision, and it captured images of galaxies forming just a few 100 million years after the Big Bang. But Hubble was designed primarily to observe in the visible and ultraviolet parts of the spectrum. To probe even deeper into the early universe, scientists needed to detect infrared radiation, because light from the most distant objects is stretched, or redshifted, into infrared wavelengths. This requirement drove the development of the James Webb Space Telescope, which launched in December 2021. Webb's primary mirror is 6.5 meters across, compared to Hubble's 2.4 meters, giving it vastly greater sensitivity. Crucially, Webb operates at extremely low temperatures, shielded by a sunshield roughly the size of a tennis court. This thermal protection is essential because any warmth from the telescope itself would interfere with faint infrared signals. Webb's early results were nothing short of groundbreaking. Within its first 2 years, it had already detected the chemical signatures of carbon dioxide in the atmosphere of an exoplanet, a first in the field. It also revealed previously unseen structures within stellar nurseries, the dense clouds of gas and dust where new stars are born. These discoveries reinvigorated public interest in astronomy and led to a significant increase in the number of proposals submitted by researchers seeking observation time on the telescope. But Webb is not without limitations. Its orbit around a point called L2, roughly 1.5 million kilometers from Earth, means that unlike Hubble, it cannot be physically serviced or repaired by astronauts. So what comes next? Space agencies around the world are already planning the next generation of space observatories. One particularly ambitious concept is the Habitable Worlds Observatory, which NASA aims to launch in the late 2030s. Its primary goal would be to directly image Earth-like planets orbiting nearby stars and analyze their atmospheres for potential biosignatures, chemical indicators of life, such as oxygen or methane. To achieve this, the telescope would employ a device called a coronagraph, which blocks starlight so that the much dimmer light reflected by orbiting planets can be detected. Meanwhile, the European Space Agency is developing a mission focused on measuring the precise distances and motions of over 1 billion stars, building on data gathered by its earlier Gaia spacecraft. The sheer volume of data expected from these future missions will require breakthroughs in automated processing and storage technology. In summary, space telescopes have evolved from a theoretical concept into indispensable tools for exploring the cosmos. Each successive generation has pushed the boundaries of what we can observe, and the missions now being planned promise to address perhaps the most profound question of all, whether life exists beyond our own planet. Thank you.
That is the end of section 4. You now have some time to check your answers to section 4. That is the end of the IELTS Listening Test. You now have some time to transfer your answers to the answer sheet.
Before you go, don't forget to like this video, share it with other test takers, and subscribe so you never miss your daily IELTS and CELPEP tests. Drop your score in the comments. Your name could be featured in our monthly Achievers newsletter. Stay consistent, stay focused, and keep leveling up with MasterPrep.